Number 9. Butane gas, which is C4H10, is often used as a fuel. A asks, what is the mass in grams of 3.00 moles of butane? Well, in order to convert from moles to mass, I need the molar mass of the compound to use as a conversion factor. So I have 4 carbons, 10 hydrogens, multiply that by the respective molar masses, add those numbers together, I get 58.119. This is my molar mass of butane. So I can take the 3.00 moles of butane that the problem has asked me, right? The problem gives me 3 moles of butane. And then I'll set up my conversion factor, which is the molar mass of butane, 58.119 grams per mole. And I'll set it up in such a way that the moles of butane will cancel out, leaving only the mass of butane, because that is what the question is asking me for. What is the mass in grams? So this setup tells me to multiply these two values and using the appropriate number of significant figures, which is 3, because then the question is 1, 2, 3 significant figures, I get 174 grams of butane. Well, B goes on to ask how many molecules are present in that 3.00 mole sample. Well, I have 3.00 moles of this stuff. For every 1 mole, there are 6.022 times 10 to the 23rd molecules of something, right? That's Avogadro's number. And I'm trying to convert from moles to molecules. That's my red flag that I need to use Avogadro's number as a conversion factor. This setup tells me that I need to multiply these values, and I end up with 1.81 times 10 to the 24th molecules. So in this 3 mole sample, there are this many molecules. And no, I do not need to use grams at all, because I have the ability to convert directly from moles to molecules using Avogadro's number. Lastly, C asks, what is the empirical formula of this gas? Well, it's butane, right? It's C4H10. And if the empirical formula is the smallest reduced whole number ratio of elements in a compound, I'm simply going to look at these two numbers, 4 and 5, and try to figure out by what factor can I reduce these two subscripts and still have it be whole numbers. Well, I can here's my ratio, 4 to 10. I can divide both of these values by 2, and I'll get 2 to 5. And so I can't reduce this any further and still have them both be whole numbers. So this is my ratio. This is my smallest whole number ratio of elements in this compound. So the empirical formula of butane is C2H5.